then where we're going to start here today is with the breakout example. Actually, we're going to first go back to the thread graphics package that we looked at. Oh, I don't know when that was, a week ago or so, maybe more. Find the right thing here. So we were looking at the thread graphics package, and we saw that we created this ball tosser example from that. And the idea of that thread graphics is that we were putting some additional, or putting a few Java classes together that we think would be generally useful in other classes for other programs. But you don't want to have to copy that code around every time you need to use it. So what we're going to do here is we're going to create a jar file. It's called a jar file. It stands for Java Archive File. The name comes, it's kind of got some historical significance to it. There used to be AR files, which were archive files, and then there were TAR files, which are tape archive files, and there are GTAR files, which are GNU TAR archive files, all kinds of things like that. So it's kind of a long-standing tradition to have these things named like that. And it makes sense. It stands for Java Archive Files. First step is to take a look at how we create one of these Java archive files. Over here in our thread graphics package, we go into the source directory. We may remember from whenever we did this, that if we go all the way down this set of directories, edu, Sienna, CSIS 225, thread graphics, we have a couple of Java files, and those have been compiled up into 3 class files. There are 3 because there's an anonymous class mixed in there. And if I want to create a jar file of this, I've already done it, but I'll do it again. The command is here at the bottom of the packages notes. And what this command is doing, jar is the name of the command. CF means I want to create into a file. And then I give it the name of the file I'd like to create, threadgraphics.jar. And then I give it the path to all the class files that I want in that jar file. You can also add some graphics files, things like that in there as well, but we're not going to worry about that. Once you've got yourself one of these jar files, looks like this, you can see what's in it with the jar TF command. I don't remember what the T stands for, but it lists the contents of the file. We see our 3 .class files are in there with their full path to them, so that's how the package knows where it lives. And then there's a manifest.mf file, which is basically like a packing list. It tells somebody who's using this, what are these classes that are in here. The video that I sent out on, this was Saturday, an example breakout, you didn't have to look at it yet. It would be great if you had looked at it. But this is an example of another program that uses our thread graphics package. It's interesting in itself. I'm hoping that I need to undo something I did in the first one here. So it's interesting in itself as an example of how we can have collision detection between graphical objects on our screen. Basically, how do we tell that this ball hit this paddle or this ball hit this brick? I'll run the program in a second after we go through this and you'll see it. But I encourage you to look at that video or read the notes about this example. I think it'll be useful for a lot of your projects. So in this repository, we've got a whole bunch of Java files, 5 or 6 Java files, and I've got a copy of the threadgraphics.jar from that other repository. Normally, if I want to compile things like this, I would just issue a command like javac star.java, and everything would be fine. Here, instead, I got 22 errors. The first error tells me the story here. It couldn't find thread graphics controller, and it couldn't find that because it couldn't find package edu.sienna.csi225 and so on. So it was not, I didn't tell Java to look in that jar file. So it didn't look in that jar file. So it couldn't find those Java classes. What we need to do is tell the Java compiler, don't just look in the standard places, but also look in that jar file when you're trying to find things that I'm importing and then later using. So I need to add an extra flag here, javac -cp, which stands for Classpath. I'm going to tell it, look in my current directory, because I always wanted to be able to find Java files in the same directory and be able to use them, but also look within the current directory at threadgraphics.jar. And then I can do my star.java. Now, everything's fine. It just goes ahead and compiles properly. Same problem I'm going to have when I try to run this thing. I run it by giving it the name of the program that has the main method in it, and it's going to give me an exception. So even though it compiled, it won't run because it says no class def found error. It couldn't find the thread graphics controller, even though it compiled. That's because when I compiled, I told it to look in threadgraphics.jar, but when I ran it, I didn't tell it to do the same thing. So I need that same flag here on my Java command that'll run the JVM and try to run my program. This time it works. And for those who haven't run it yet, here's my program. It's inspired by an Atari 2600 game I had just a few years ago. You play this game, the ball bounces. If you hits the paddle, it goes up. If it doesn't hit the paddle, it doesn't go up and you lose your turn. This one's kind of crazy because you can have as many balls in play as you want. And my they get a little over aggressive sometime with their destroying of the bricks up there. Not the best job of programming on this, but it gets the idea across for the collision detection. And it's another example of a program that makes use of our thread graphics package.
I have a question.
Yes, sure.
So when you were compiling that code with the class path, does that colon just mean to have multiple directories? And could you have a second colon if you had another jar?
You could. Yep. You could list a whole bunch of things there.
Okay.
Yep. But nobody wants to type all that, right? So every time you type Java C and Java, well, first, you're probably doing this in some kind of an IDE that has its own way of setting jar files to search. So in the notes, it tells you where to find the right place in BlueJ if you wanted to use BlueJ. Others would have their own. I like to deal with things at the command line. But if I was going to be working in this program, I would set my class path variable. And it's called an environment variable. And if you're in Git Bash, or if you're in a Mac terminal with Bash as your shell, this is the kind of thing that you would like to put in. I am using a shell called TCSH instead of Bash, so my syntax is different, but the idea is the same. If I set the environment variable class path, oops, yeah, I'll just type it. I set this variable class path, then any program that might care about class paths, such as Java C and Java, will automatically find that. So I can just now do my standard Java C star.java, and it's as if I had to put that -CP flag on there. And I just don't have to type it every time. If you're doing large-scale Java development, again, you're in an IDE, or you're going to have some sort of a build system that'll set your class paths for you, so you're not typing that kind of stuff in. But anyway, that's good enough for our purposes for today on that. Are there any other questions on creating and using a jar file?
If you were to close your command line and open it back up, is that environment variable persistent or no?
It is not.
Okay.
If you want it to be persistent, you put it in one of your startup files. So like mine, I've got this startup file that I built over the course of 30 years of using Unix that has all kinds of things set up for me, and it runs every time I start a new shell. It probably has a class path in there from some other purpose, but you can set these up as well. I'm happy to help anybody with that who's interested in doing that. If you want to use the command line and get that set up, I can help you do that.